Okay, so we're going to take a look and see what the value of k is, what our problem is all about. We know the area of the rectangle is 128 over 9. Well, even though it doesn't look quite like it, these rectangles by symmetry must be the same. So this area here has to be half of 128, so that area is 64 over 9, and we're going to work with that area. We know that area of a rectangle is base times height. Well, here's the base, and here's the height, which is dependent upon b, which is the x value and the y value. So if I can find that coordinate for b, I can find the area. Well, my y value is k. Well, these two functions intersect there, so I can let k equal 3x squared. So k over 3 equals x squared. And so x equals the square root of k over 3. So that's my coordinate is square root k over 3k. So my area then is base times height is square root of k over 3 times k is equal to 64 over 9. So solving this equation, we're not allowed to use a calculator. So it's a lot of exponent work, which is tricky, but you've done it before. You just have to take it one step at a time. I'm going to rewrite the k as the 1/2 and k. And while I'm at it, let's multiply both sides by root 3 so that they come along and they cancel. Okay, so I know this together is going to be 64 root 3 over 9. And if I multiply these two k's, I add the exponents. So 1 plus 1/2 is k to the 3/2 is equal to 64 root 3 over 9. And so now I need to solve for k. What I can do, the easiest thing to do is put it to the power 2, which gives me k cubed is equal to 64 squared times 3 over 9 squared. Now I have to remember I'm not allowed to use a calculator, so I have to work with my exponents. Well, k cubed, 64 I can rewrite as 4 cubed squared times 3. And 9 squared I can write as 3 squared squared. Which means then that k cubed is 4 to the 6th times 3 over 3 to the 4. I can simplify that to 3 cubed. And so now, when I raise this to the power of 1/3, or cube root it, I get k is equal to 4 squared, because I multiply those, over 3. Otherwise known as k is equal to 16 over 3. That is the k value for this problem.